Hello and welcome to another Monday night Q&A session. I'm joined tonight by my colleague Dean Kinsella from the Area Engineers team. Good evening, Dean.
Good evening, Sam. How you doing?
I'm good. How are you?
Not too bad. How was your weekend?
Yeah, it was good. Too quickly as per usual, but yeah, I was out in the sun. You can see I've got a bit of sunburn. No sun cream. Wasn't expecting it to be as hot as it was.
No, you got caught out there. And how about the football today, Sam? What's about the sacked?
There's it's gone crazy, isn't it, today with the announcement of the teams leaving or possibly leaving. But I was listening to the news there tonight, and they were saying it might just be a bit of a scare tactic to get more power in the Champions League, because they were starting to talk about them being banned from domestic competitions, being banned from playing for England. Obviously some changes. But I can remember before the Premier League days. So that was a big
the old first division.
Yeah, that was a big kerfuffle when that all came in. So I'm sure there'll be some changes.
Well, we'll see. Controversial though.
Yeah. Oh, look, you see, we've already had a question in the chat room. Is the NIC joining the Super League? Well, we can't possibly comment on that, I'm afraid.
But Super League.
a very good question.
I'm joking.
Okay. We'll have a quick look at the question of the week to start off with. So for those that perhaps haven't had a chance to see it, the question of the week this week was on an industrial installation, I'm using 100 amp BS88-2 type fuse, which has a maximum permitted ZS of 0.42 ohms. But my external loop impedance, ZE, is already 0.47 ohms. So what can I do to comply with the requirements of ADS? A question we from time to time get asked along similar lines. It's a situation where effectively the incoming impedance is already greater than your protective device's maximum impedance. So what kind of options have we got to overcome that, Dean?
Well, I suppose there's a couple of points that you could consider. I think the first one will be discussing it with the DNO to see if there's any way that they can reduce the incoming ZE at the origin to get it below and therefore give a suitable reading just to start at that point of origin. I guess it's going to be easier said than done, just picking up the phone and asking them what they can do about it. So that's one option, but it may not be the best option. I suppose other options we could look at is installing a different protected device at the point where the reading is too high, I suppose, and then depending on the device that you install, the BSCM number and the type may give a less of a maximum disconnection time ZS value, which would then help to comply with ADS. Another option, I suppose, you could provide RCD as a means of fault protection. Again, there could be a cost factor involved depending on the size installation and the type of RCD required. And the downside, I suppose, is the RCD with regards to nuisance tripping. One single point of failure, the whole installation goes down. And then that's going to be a departure with regards to other regulations then, where you're not offering that subdivision across the circuits. So there's probably the main three options that we could consider. However, we do have a fourth option that we can throw in there if we wanted to, and that's going to the regulations itself and looking at another method that not a lot of people know about this, Sam, but we do, and that's why we're here. So for those of them that aren't too sure, Section 419, discussing obviously ADS, where the regulation 411.3.2 is not feasible. 419.3, for those who've got your book handy, quickly have a look in that, bring up the page. And what it talks about is where the disconnection time cannot be met by the aforementioned regulations, Supplementary protective equipotential bonding can be provided in accordance with Regulation 415.2, and the voltage between the simultaneously accessible exposed conductive parts or extraneous conductive parts should not exceed 50 volts AC or 120 volts DC. Obviously, I'm reading from a little bit here as well, but basically there's a number of options on there. All have their pluses and minuses. I suppose what you've got to consider is the amount of metallic parts available at the origin in which you can bond to. So you're looking at metallic structure, which will help to bring that Z value down to meet the disconnection time. But yeah, numerous options.
Yeah. So it's as you said, Dean, that 419 section, it's been broken out now into the 18th, so it's far more apparent. It was always in there, but it was kind of hidden in amongst the regulations, and it's the case whereby you will disconnect. So you're in the example in the question, the person's 100 amp fuse will disconnect eventually. It perhaps just won't disconnect within the 5 seconds disconnection time required for ADS. So what we say is that for the time it takes to disconnect, we've just got to ensure that everything that's simultaneously accessible is supplementary bonded to make sure that for the time that fault exists, no two parts which are conductive, which are accessible, are going to rise in potential greater than 50 volts. So you know what your fault current's going to be. You know what you can calculate what size cables you're going to need for the supplementary bonding to ensure that 50 volts. And I've seen this is sort of most commonly done in intake rooms, in areas where we've got a large plant. The incoming supply is fairly large, but which means our protective device is so small that we can perhaps not achieve the 5 seconds, but we will eventually disconnect. But all our outgoing circuits from that intake room have got a much smaller protective device, so they're fine. It's just that incoming supply cable that gives us the concern. So yeah, it's a regulation. It was one of those real light bulb moments when somebody showed me that regulation, because otherwise you kind of think, oh, I'm stuck. If the DNO can't help me, if I don't want to put an RCD up front and they won't accept me down rate in the fuse, I'm kind of stuck. And that regulation allows you to have a third option, which is really useful.
Yeah, it is. It's a good one. And obviously there are situations out there where you're going to come across this, and to be mindful of this regulation is really going to serve the purpose. If you come to, like you said, a position where you're stuck and there's not many alternatives available. So it's definitely a good question of the week, that, to be fair.
Okay, so well, let's have a look at some of the other questions. Two questions made into one. On an EICR, if two properties such as two commercial units with its own supplies were made into one and there are circuit crossovers, you wouldn't normally install main bonding between the two, as they would be extraneous to each other, even if one was a TNCS and one was a TNS. But on an outbuilding scenario, you would divorce the earth system from the house, for example, if it was TT outbuilding. So okay, I think one of the things that we quite often get asked is where we've got large buildings that perhaps have got a supply, typically one supply at each end, and those two previously separate buildings are now knocked into one. What's the situation with, obviously, that they may have a different earthing system. They may, even if they're on the same earthing system, they may have a different potential due to the supply network. So I think the scenario there is if within the installation there are areas where the supplies are not segregated, so you could touch two things which are earthed to the two separate systems, then you've got to think about creating an equipotential zone by bonding the two main earth terminals together. So effectively you create one equipotential zone by ensuring that the two earthing systems are at the same potential. If they are simultaneously separate, so there are no areas in the plant, perhaps due to physical barriers like internal walls, so there are no areas where the supplies are mixed, then it's not an issue. But if you've got the situation whereby there could be areas within the building where you could touch something that's earthed or bonded to supply A, and simultaneously touch something that's earthed or bonded to supply B, then we have to make sure that they're at the same potential. So that's where we'd join the two main earth terminals together. Would you add anything to that, Dean?
I was just thinking, I was trying to picture in my head such an installation and looking at various things and other considerations. Obviously, what you're rightly saying, if you've got class 1 present, obviously there needs to be a simultaneous bond between the two air paths. If there's class 2 present, I guess obviously it creates a different scenario. And also, not that it may happen, but I'm just thinking outside the box. And also another thing to consider, which may not be applicable, we're talking about where you can access 2 points, where there's going to be a potential. But if you've got cables that are crossing past each other and you've got the insulation in place, then that's something that wouldn't necessarily need to be considered. So you've painted a picture. So I'm just putting a few little dots in between there, rather than people thinking that every time they come across 2 supplies, they have to bond it all. It's not always the case. There's other considerations where the simultaneous contact may be avoided as well, through your class 2 accessories and luminaires, and obviously where cables are running parallel to each other. It's not exactly where you can grab hold of both, because there's outer insulation present as well. So I was just thinking outside the box there. That's not always that black and white. There's other things that they've got to look at within the installation, and the type of wiring methods and the type of equipment and accessories fitted as well.
Okay, yep. A question that we've got in the chat. Can you wire a 20 amp switch from a ring for a cooker, either changing a socket to the 20 amp switch or a radial off the ring? The first thing that springs to mind for me there would be potentially overloading the point of the ring that's connected to. There's some guidance. It is only informative in the appendices of the regs, which recommends nothing over 2 kilowatt as a single load on the ring. It should be given its own dedicated circuit or part of a radial circuit that's rated appropriately. So if we're talking about a 20 amp device at 230, then that's going to greatly exceed that, and you've got the potential danger of overloading the leg of the ring that you connect it into. The regulation which talks about standard ring circuits and standard accessories talks about a 20 amp minimum rating for the circuit conductors of a ring circuit. So you can see that by putting a single device which is 20 amps on its own, you're going to greatly reduce any other potential loads on that ring. So that would be my concern. You know, you've got a very heavily loaded point that then means that leg of that ring, if we look at each sort of 2.5 mil leg having a typical 27 amp current carrying capacity, if the cooker's on and fully loaded, you're going to be taking the majority of that, which means you've got very little else. So any other thoughts on that? 20
I
amp
think
cooker?
you've hit the nail on the head there, Sam. I was just thinking of the scenario in which they've asked the question, most to do with the kitchen. Obviously doing adaptations in the kitchen, and they want to make it easier by tapping off the ring circuit and cutting into it. But I think what you've rightly said, it's not the best practice, and the better practice would be to run a new or additional radial circuit at the current rating for the equipment that needs to be installed. So you know,
There's nothing that explicitly says you can't, but you would need to strongly consider the load that's going to apply to a single point on the ring. And as you say, the recommendation is nothing over 2 kilowatt. So you'd have to have a strong reason for going against that recommendation.
Yeah.
Let's see what else we've got. On a TT supply, have MCB to protect the sub-main cables, then install an RCD in the new outbuilding to meet the disconnection time instead of at the start with the MCB. So I'm just trying to scroll backwards to see if that's a response. So typically on a TT supply, we're not going to be able to survive with a breaker or a fuse because of the high impedance.
That's
So yeah, I don't know if I'm missing the start of that question. On a TT supply, have MCB? It may be right. We'll go back a little bit because this might be the start of that. I'm constantly being asked if TT systems require double pole RCDs or RCBOs. Am I missing something? Is there a reg that requires this hidden somewhere? In certain situations, there are lots of circuits that require double pole isolation. You know, I'm looking at things like vehicle charging where it's a double pole RCD. So BS7671 does specify in particular situations. I don't think it's a blanket requirement across TT installations, but the thing that strikes me about TT is that obviously in a TT installation you can't guarantee that the neutral's going to be at earth potential. So in TT we always need to be able to isolate the neutral, whereas in TNS or TNCS we don't. So in TNS and TNCS effectively we can use a breaker as a means of isolation because the neutral is considered to be deemed as close as near it is to true earth potential because of the way that it's referenced within the distribution network. So I don't know if the question's coming from that angle, in which case then we would have to have double pole if we wanted to make sure that that device, as well as providing fault protection, also provided a means of isolation, because the regs do tell us we have to provide a means of isolation for every item of equipment, every circuit and every installation. So if we are using the protective device to provide a means of isolation for the circuit, then that protective device would have to be double pole in a TT installation. But yeah, perhaps give us a bit more information about that question.
Yeah, there's no mention of RCD there, is there? It's more to do with the double pole switch side of things. So
yeah, okay. Let's see where else we can go. Recent EICR found 16mm twin and earth submain, straight off link boxes without a switch fuse, feeding a dual RCD consumer unit on the first floor. The twin and earth is concealed in the wall. Can I fit a switch fuse to the existing cable, or will the cable have to be replaced too? Well, I'm thinking there's two things there. One is, with it being in the wall, it should really be provided with additional protection, and also with it being 16mm, it may not cope with, well, it wouldn't cope with the supply if it was protected with a 100 amp device. So a couple of points there. So just reading that back again. Recent EICR found 16mm twin and earth submain straight off link boxes without a switch fuse. So I'm guessing he's confirming there's no independent overload protection other than the cutout fuse. And then it was feeding a dual RCD consumer unit on the first floor. So we have got RCD protection on the outgoing circuits. The twin and earth is concealed in the wall. Can I fit a switch fuse to the existing cable, or will the cable have to be replaced too? I think it's one of those ones on an existing installation. if the cable's buried in the wall without additional or without evidence of additional protection, so no RCD, no evidence of mechanical protection, we would suggest on an EICR that's a C3, would we not, Dean? Yeah.
Yeah, I totally agree with this, Sam. Yep, C3. Yep.
So I think if we then look at the case of, I think the inference is, and I might be jumping it wrong, but the inference is that the questioner thinks that it's not adequately protected against overload. So by fitting a switch fuse, he could repair that situation and make it better. But wouldn't necessarily have to go the full way and provide additional protection to be able to reuse the cable. It would be a recommendation, but not a requirement because it's an existing cable. Would you agree with that?
Yeah, no, I totally agree. I was just thinking about the different codes there. Obviously, the overload side of things, you know, you'd have to determine the amount of circuits that's on the fan circuits that's within the fuse boards on the first floor. If it's got the potential to draw more than the current carrying capacity of the 16 mil with the supply fuse, that'd be one consideration first and foremost. Obviously, if that is the case, and then he fits a switch fuse to provide that means, then that'd be fine. But then, I suppose, looking at it from a condition report point of view, you're still going to have elements of C3 there. Now, I know some housing associations and specifiers request all C3s to be rectified. Obviously, if that's the case with this particular periodic inspection report, periodic inspection testing with the condition report, you'd have to look at other means of resolving the C3 as well, which might mean resupplying the fuse board on the first floor either with an armoured cable or surface mounted.
Yeah.
There's a few things there.
Yeah, so that would, if they wanted to remove C3s, you would be looking at you know, a new wiring system there, either like you say SWA or putting it in metal conduit or protecting it with steel plate, or as you say, putting it on the surface. So yeah, we want to try and avoid 30 milliamp RCD protection, because then that really doesn't fall into line with the final circuits that are going to need 30 milliamp RCD protection. So yeah, you would be looking at mechanical protection to provide that additional protection required.
Yeah.
Okay, let's have a look. We got, do meter tails in the wall from the meter to the dB need RCD protection? Well, if they're buried in the wall at a depth of less than 50 mil, they need additional protection. Now, whether that's in the form of an RCD or a mechanical protection, that's the designer's choice. But as we were just talking, our preference would be for distribution circuits to try and do it with mechanical protection, so that you don't negate the selectivity issues with 30 milliamp protective devices on your final circuits.
Yeah.
Let's have a look at what we skipped a few, so we'll just go back a little bit.
Just while you're looking, I'll just talk a bit about that last one.
Yeah.
I guess regard the supply tail, it's not often you're going to come across the supply tails being less than 50 mil. The only times I can visualise is where you've got the external meter housing and the cables come from the external meter internally up the wall and then reach the fuse board on the inside of the building. Generally they're in between the two brick layers, which is going to make them more than 50 mil. I don't think you hardly ever see them where they're within the plaster less than 50 mil. Not that it doesn't happen, but just looking at, you know, how often it does happen, and like I say, that the methods of rectifying it.
We've got one in TT. So on a TT system, 230 volt, the disconnection times are 0.2 seconds and 1 second, as opposed to the 0.4 and 5 seconds on a TN system. Does this mean on the RCBO for fault protection on a 13 amp socket circuit, it must trip within 200 milliseconds for earth fault protection to comply with 0.2 seconds? Just that 61009s can take up to 300 milliseconds. So yeah, you're absolutely right with the 0.2 seconds for your socket circuits up to with socket outlets rated up to 63 amp, or for your fixed equipment. So you do need to achieve that 0.2 of a second. So what you've got to do is you've got to measure your prospective earth fault loop current and make sure that it's going to be greater than the nominal rating. So you're absolutely right that for the nominal rating of the device, for example 30 milliamp, it may take 300 milliseconds, which would be outside your 0.2. So you've got to ensure then that your ZS is low enough to create a current which is greater than the 30 milliamp, greater than whatever the nominal rating is, to ensure that you get a tripping time greater than 300 milliseconds. So yeah, it's a little bit more onerous on the designer to ensure that they're getting a low enough earth fault loop to create a fault current which is going to ensure you're going to achieve that 0.2 second disconnection time. So you know, normally even on a TC system where you might have a 200 ohm earth fault loop path, you know, your fault current is still going to be, you know, even on 200 ohms it will be around an amp. So you know, you should achieve quicker than the disconnection time of the ×1 rating for your device, but it's a check that you've got to go through.
Yeah.
Okay, let's have a look. They're coming in very quickly tonight, so the system keeps jumping, and I'm conscious that I'm missing some. So we'll try and go back each time. Hi, lighting switch on worktop kitchen. It's a fail as well as socket 300 millimeters away from the sink. What happens if it's 350 mil away on a diagonally up? Thanks. Okay, so yeah, the guidance for accessories from the edge of the bowl of the sink is 300 millimeters, and I think that's based on them being 150 mil above the work surface. So you know, that's good guidance. I think on an EICR, if they're closer than that, then it's, well, even on an EICR, if you've got concerns, it's always worth safe isolating and actually opening up the accessory to see if there's any signs of moisture or water ingress, and that's when you might code it with a danger code. If there's no signs, but you believe it could be improved because it's less than those recommended measurements, then that's where you might consider a C3. But yeah, it really does look, and I take the question's point is that 300 mil away from the edge of the sink. If you go higher, then yeah, you could actually be inside 300 mil and still achieve that same diagonal distance. So it's one of those ones that it's a guide, but you've got to use some engineering judgment based on how high above the sink is it as well. Let's have a look here. Got an issue on an EICR where the main gas pipe that enters a block of flats is bonded in the landlord's service riser. Do each of the flats that has a gas meter located inside have to be bonded, and if so, from each of their DBs or from the landlord's MET? Now that's a really good question that we debate often about a block of flats and where the bonding's requirement. I think it very much boils down to is it a single installation, i.e. is it one supply in, one metered supply in from the network operator, and it's then distributed through to the flats. So is it a single electrical installation? And also gas wise, once the gas pipe work comes into the building, and if it's adequately bonded to the MET of the electrical supply, does the gas service pipework then remain internal within the building as it travels up to each of the flats? Because if it does, and it's adequately bonded at the point of entry, then there's no requirement to further bond it within the flats, because it's effectively one large electrical installation, and we've bonded in compliance with the reg that tells us to bond as near to the point of entry as possible. So if it's a single electrical installation, and if it's a single gas supply that comes into the building once and remains in the building, then there's no requirement to bond further, providing it is adequately bonded at the point of entry into the building. Yeah. Any further thoughts on that one, Dean?
I was just going to ask, you mentioned about remaining in the building. Are we talking about if it leaves the building and goes back into the mass of earth?
Yes.
And re-enters at another part? Yeah.
Yeah.
Okay. Yeah.
So
I just didn't want the viewers to get confused about when it comes out the building, as if it runs on the outside wall, where we mean into the mass of earth, and then it re-enters the installation at another part. Then obviously you'd have to consider a bond at the far end. Yeah.
So if it sort of dives under the ground to get to the back of the building, then when it re-emerges, it could again reintroduce that earth potential, and so would need to be rebonded.
It's always good to do the check anyway, Sam, isn't it, within each of the dwellings? Go from your MET on your fuse board to the various extraneous conductor parts. Make sure you've got a nice low resistance in there.
Yeah, no, absolutely, because it's it makes a difference, deciding whether we need to bond something or not. And if something doesn't need bonding, you can actually make it worse by bonding it, because now you're making it liable to carry fault currents, which if it was an isolated piece of metalwork, there's no way it could. So I think the adage of there was, going back a few years, be on the safe side, bond it. I think we question that now a little bit, to sort of say, don't, confirm, do the inspection, do the practical tests to try and confirm whether it is extraneous or not, and whether it needs bonding. If you can confirm that it's not extraneous, then it doesn't need to be bonded.
Spot on.
Okay. On the ICR within a bathroom, if no RCD is on the lighting circuit and no supplementary bonding found, if all copper pipes are tested to the MET and prove that they are not extraneous over 23 k ohms, would you code 3 this or code 2 it? So if we're saying that there's no RCD but there's no extraneous conductive parts, so no supplementary bonding's required, then we would see 3 it, because if there's no supplementary bonding required, that's the same as having adequate supplementary bonding. It's just a kind of reverse. So I think the general guidance we give is lack of RCD protection with adequate supplementary bonding, we recommend as a C3. Lack of RCD protection with inadequate supplementary bonding, that's where we recommend the C2. So in the case where there's no supplementary bonding required, then again we would go with lack of RCD protection, recommended as a C3.
Yeah.
So recently tested a TNS supply with 1.8 ohms at dB. Was told I didn't need to provide fault protection to supply tails to disconnect within 5 seconds. Only way to do this would be to install 100 milliamp time delayed RCD in line with tails. All circuits within dB will have 30 milliamp protection. So yeah, that's one. I think we're going back to almost the original question there, where if you have got a high ZE and it's stable and the DNO are confirming that they're not going to do anything to improve it, but it is in their mind stable, then you could look to put 100 milliamp time delayed on that circuit if you can't meet the ZS of the protective device. And then that 100 milliamp you'll achieve your ADS. It will be adequate for fault protection, but the beauty is then that it will also give you selectivity or discrimination in the old language with your 30 milliamp devices downstream. So yeah, not an issue. I would want to find out, why is it 1.8? That's high for a TNS system, but ultimately we're in the hands of the DNO if they say it's adequate. But you might want to consider that when you're thinking about period to the next inspection. So especially if you've got records that it was lower than 1.8 in the past. But again, I appreciate it's not, most places we go to, there are no records, there's no previous condition reports, there's no previous installation certificates. So yeah, you might factor it in when you come to recommend the date of the next inspection, just to make sure that it's not getting any worse.
Yeah. Might be a good one to reduce the inspection interval on something like that. Yeah. And to obviously check up to see if that Z value is deteriorating rapidly or not. Okay.
Last one then. We've rattled through time again, so I do appreciate. I must say thank you very much for firing the questions in today. It's been really good, and I do apologise if we've not got round to your question. We will try and mop some up with a question of the week in the future, or try and bring them together so that we've got a themed evening. But we'll just look at a last one now. All bands used to support a PVC submain to a flat. Council said it can't be used, must be tray, but tray not in their spec. What's wrong with all band? Well, two things sort of spring to mind. Is first, we've got to ensure that we've if we're in a situation of premature collapse, then it must meet those requirements. So we've got to ensure that we're not reliant on non-metallic means of support for our wiring systems. But ultimately, if a lot of these things can be contract driven, can't they? So if the designer, if the customer's architect or the customer's designer chooses a particular method, then they can write that into the contract, and that might be over and above the requirements of BS 7671. So sometimes I think we forget BS 7671 is a minimum standard. We can always go enhanced, we can go above that, and architect and designers, consultants can often specify more onerous requirements than 7671. What they can never do is go below. So do you find that in larger projects, Dean, that often it's spec'd?
Yeah. Generally, and as I say, going back to a lot of the councils, they generally do overspec. Sounds like they're being too harsh, but they work from BS 7671 rather than to it. So they may specify a higher degree of the installation with regards to galvanized tray in comparison to a more simplistic method of supporting the cables in the event of fire. I think the thing that we've got to consider here is all band originally in its entirety has been used to support cables, but you'd have to go back to the manufacturer and check if all band, as we call it generically, is also suited for support of cables in the event of premature collapse as well. Just because it is non-metallic, my apologies, does not necessarily means it could comply. You'd have to go back and check their specification on that one.
Yeah, but it's fair to say sometimes with councils, the sort of the design mentality and considerations are often driven by maintainability, aren't they? So they want something that's going to last a long time, and it's going to be easy to rewire. So this is why, you know, you quite often in the older properties, certain in the London area, you used to find conduit embedded in the wall so that you could easily rewire. You know, you fed through. And it might be something similar as their preference for tray, because they might see it as easier to rewire once you've got the support system in place. So that might be the consideration and the reason why they've gone down that way.
And making allowance for scope as well, depending on the tray size requirements, might be for future use as well, rather than having to reclip another cable which looks unsightly. So it's maintainability, serviceability considerations, definitely with councils, yeah. But then he did mention that the tray wasn't in the spec, so it just seems a bit of a strange one, because he did mention that in the question.
Yeah, he says council said it can't be used, must be tray. No, council said that tray must be used. That all band couldn't be used, and that might be. It's just a guess. That might be about the maintainability. So once the tray's in there, you know, in 30 years' time, it might make it easier to rewire.
Yeah.
Okay, we'll draw a halt to it there tonight. As I say, thank you very much for those of you that contributed with questions and support to your colleagues as well in the chat. It's much appreciated, and we will go through them to pick out the ones that we didn't get time to do tonight. I also, before I disappear, want to just remind you that you've got the latest episode of The Wire, which is our series of technical webinars. There's this week's webinar is on electrical supply to hot tubs. So it was probably a top question this time last year going into the summer. So that'll be a good one to take part in. So that's at 8 p.m. on this Wednesday, the 21st of April. So if you want to watch it live, please go onto the website and pre-register. If you can't watch it live, you will still need to pre-register to be able to watch it in your own time. But that will be good, and hopefully will answer a lot of common questions that we get around hot tub supplies. So many thanks for your time tonight. Any last words, comments, Dean?
No, just thank you once again for your time this evening. Hope it was beneficial. Those who missed out on the questions, like Sam said, you can put an email to technical helpline. And those of you who are NIC contractors, then don't forget to record this as your 30-minute CPD as well. So,
yeah, good valuable time. Okay, thanks very much, people, and you know, don't forget. Book up for Wednesday, and hopefully we'll see you again next Monday night. Okay.
Yeah, I'll be watching it, so I'll